Good morning. So today we are going to continue on our discussion of motion. And so with motion, we knew that an object was in motion when it changed its position relative to a stationary object. So if I am sitting in my chair relative to the desk, I am not moving. I'm not changing my motion. I'm not changing my position. So I don't count as moving. But if I change my reference point and I say, well, am I moving compared to the sun? The answer is yes, because I'm always rotating on my axis and revolving around the sun in our giant orbit that takes 1 year. So we then moved on and talked about distance and displacement. Remember, distance is abbreviated with a D. Displacement is abbreviated with delta x. For distance, this is our total path. This would be measured in meters, feet, miles, kilometers, any of those. For displacement, this is my straight line distance or my change in position. So my straight line distance from start to end. Remember, with your displacement, it does not matter what happens in the middle. So if you end up at the same spot at the end, then your displacement is 0. Remember, displacement is a vector quantity. That means that it comes with a number and direction. Remember, your direction could be north, south, east, west, up, down, left, right, forwards, backwards, positive, negative, all of those would count. Units are still the same, meters, feet, miles, kilometers, but again, I would include that direction, which is really important. Then you guys took a look at speed and velocity. In order to calculate my speed, I just take my total distance and I divide it by my time. So if I'm taking distance divided by time, I'm going to get something like meters per second, miles per hour. Those would be some of my units. Speed is a scalar quantity, which means it does not have a direction. Velocity is my change in my position, my displacement over my time. This still is going to be meters per second or miles per hour or kilometers per hour, but this one also comes with a direction. So we say that velocity is also a vector quantity because it has that direction attached to it. So are you traveling in the positive direction or the negative direction? Are you going north or are you going south? Okay, so you have distance, displacement, speed, and velocity. So those are going to be our 4. Now, remember, my distance will be the same as my displacement, and then my speed will be the same as my velocity if I travel in a straight line and I do not change directions at all. So if I'm traveling in a straight line and I stop here, so there's my initial position, there's my final position, then my distance is the same as my displacement. Okay, which means then the speed will also be the same as your velocity. Now the last thing we have to discuss is acceleration. So for acceleration, that's going to be abbreviated with an A. So A is your acceleration. And so with your acceleration, you can either speed up, you could slow down, or this one is kind of weird. Now, a lot of people don't like this. Acceleration is a change in my velocity over time. So I'm going to take my final velocity minus my initial and divide it by time. Well, since velocity is a vector quantity, that means acceleration is also a vector quantity. So in theory, could I be going 30 miles per hour around a roundabout and still be accelerating? The answer to that one is yes. So you can also have an acceleration with a change in your direction. So even though the magnitude, the number, may not change, I can change my direction. So again, acceleration is the change in the velocity over time. In order to solve for that, I take my final velocity minus my initial and divide it by time. So for example, all the car commercials say I can go from 0 miles per hour to 60 miles per hour in 3 seconds. Okay? Well, I could do my acceleration is the change in velocity over time. So I went from 0 to 60. So final is 60 minus 0. And then for my time, it's 3 seconds. But if you look, this one was miles per hour. So I'd really like to get my seconds into hours, and then I could solve. Or understand that when I gave my final answer, I would have a positive acceleration because I sped up of 20 miles per hour per second. If I leave that as seconds, those seconds still come along, okay? If I had changed it though, let's say that instead of saying 3 seconds, I say in 0.1 hours. So now my acceleration is my change in velocity over time, 60 minus 0 divided by 0.1. So I have miles per hour and then divided by hours. So 60 divided by 0.1 would be 600 miles per hour squared. So a lot of people are like, wait, why is the hour squared? Well, if you follow your units, miles per hour divided by hours, most people don't like divided by, so you multiply by the reciprocal. So miles per hour times 1 over hours. So multiply across, miles times 1 is miles, hours times hours is hours squared. So my units are always going to be something like meters per second squared, miles per hour squared, kilometers per hour squared, in addition to also having a direction, okay? So if you speed up, your acceleration is going to be positive. If you slow down, it's going to be negative. So you might have heard a common term that is often used called deceleration. Deceleration isn't actually a thing, right? So even though that's common verbiage that you might hear out in society, in the scientific community, deceleration is not a thing. So please don't use that word. Speak of it as a negative acceleration because you're slowing down. Now again, with that change in your direction, so since the acceleration is a vector quantity, meaning that comes with a number and a direction. If I want to accelerate, I can either change the number, and that would be by speeding up or slowing down, or I could change the direction. So this is where that weird one comes in, of if I'm going around a roundabout, okay? If I look at every instant in time, my velocity, if you look, it's just tangent, is changing direction. So even if I'm still going 30 miles per hour, which that's a little fast in a roundabout, if I'm still going 30 miles per hour, so the speed portion, that velocity portion stays the same, but the direction portion changes, then I know that I do have an acceleration. So please, if that does not make sense, please rewatch this, look at it again, because I know that does trip up some students, okay? Same deal if I'm driving and I'm going 25 miles per hour down the road and I hang a right really quick and I'm still going 25 miles per hour, my direction has changed. I was going north, now I'm going east. So because of that, yes, there was an acceleration, okay? All right, so today what you guys are going to do, you're going to practice a little bit on calculating for acceleration, and then that way you feel pretty good. On Monday, Tuesday, we're looking at doing a small quiz, just going over calculating and knowing the difference between distance, displacement, speed, velocity, and acceleration. So it's just going to be these 5 things that will be on there for you. All right, you guys have a great day. I will talk to you later.